Okay.
Thank you, Titina. Hi everyone, my name is Ogin Tanovic, and today, as Tatjana said, I will talk to you about NLP pipelines with example in real life use case. We have data set with about 500,000 reviews, and we will try to build some story about sentiment analysis task and see how much successfully we can solve it. Generally, we will, for whole this workshop, we will talk about supervised learning, unsupervised learning techniques in both of those branches. Also, we will experiment with applying supervised learning techniques on unsupervised type of problems. At the end, we will measure success of all of these techniques. But for now, as we plan to dive deeper, a little bit deeper in NLP pipelines and cover multiple use cases in parallel and apply multiple techniques in parallel and measure success, every of them. As Tatjana said, we split the workshop into two parts. Today, we will cover just supervised learning pipeline. As part of our audience today and maybe in the future who will watch these records of this session might not be data scientists, maybe just interested in data science. I will use this part of this introduction part to present ourselves, where and why are we needed, which problems we solve, and in the same time we will set up a goal for our today task and experiment. So who need data scientists? Usually we can split business by three major sizes. First are local businesses. Usually owners of those businesses are people who are in the same time workers. They interact with their customers every day. They listen feedbacks there, and they can reshape their business according to those feedbacks. So on this level of business, data flow is low, and usually owners manually process that feedbacks in order to make right decisions. Next level is, let's say, medium size. Country level players already on this size, depends on company size and country size. Amount of information is already medium or high, and already on this level owners can need us to solve some of their problems. On the other hand, they can solve some part of those problems with BI tools like SAP or Oracle B. But already we are here in the edge to apply data science to solve problems with insights and process of data. And the third level is global players. On this level, amount of information is huge, big data. For my opinion, on this level, data science doesn't have a competition. Players on this level apply exactly data science to solve their problems. So what tools and which skills data scientists have? We use a wide range of techniques to solve problems. I will not count them all now, but just for overall, you can sometime go back and see all of those disciplines which we apply to, as I pointed here, to transform raw data into valuable business information. Okay, enough about us. Let's come back to client. especially in previous last couple decades. Um, Business owners realized that customers talks on different places like forums, like social media, like I don't know, all over internet can be really, really valuable source of information, which can make them to make correct decisions in which direction to develop their business, to make overall score, how they do well over time even. And also maybe to determine exactly in what part of their job they are good and what part is problematic. Only problem is that amount of informations on internet are huge. So in millions per day, you know, if company is well-known, popular brand, they have millions of comments about them every day. So they, in that moment, contact us, employ us to solve that problem. When we start to find a proper technique, okay, we set up a goal for our today. In the same time here, we set up a goal for today workshop. So we need to answer two questions. Client want to know overall brand score, maybe company score, maybe particular product score, and reasons why that score is like that. What people like, what don't like, exactly. First question, what we ask when we start to dive into problem is what data we have. Are data labeled or not? According to answer on that question, we decided what branch of machine learning and data science pipelines we will use. If data are labeled, we will use supervised learning. If not, unsupervised learning. So today we will dive deeper in this part, which is known as supervised learning. Usually people who doesn't know data science well say, why I need supervised learning or machine learning at all if I have already labeled data. I can do just like averaging, you know, and got a result. But that's only partially true. In real life, labeled data are rare. They are very expensive, and usually we get raw data without any labels and by ourselves or together with domain specialists, we just label part of the data and then label and predict rest of the data set. On the other hand, just it's enough to don't forget that for business, usually it's not enough to know overall score. They always want to know more, like what's the reasons, why that or that, and so on. So just simple averaging is not satisfies the business. Okay, here I prepare for you now. I'll try to zoom a little bit this flow chart. This is Google developers flow chart, how to properly choose techniques which you should apply on your NLP program. On first two steps, we see token mode and vectorization mode. So let me explain what that means. Token mode means we need first to determine our scope of interest inside text. So are we interested in characters or words? For example, if we have a problem like autocomplete word, then our scope would be probably character-wise. But in our case, for today, for example, we have binary classification, which is sentiment analysis in the core. One for good positive sentiment, zero for negative. So token mode on word level is enough for us today. And second decision is vectorization mode. Vectorization mode means what part of text we count as relevant for our predictions. Again, let me come back to autocomplete problem. Usually for autocomplete problem, last couple samples of something, characters, or last couple words determine what is next word, not overall picture. In our case, overall picture is good to determine does someone have good or bad experience when he talked about it. So already on this level, we have a good direction. Where should we go in this split to sequent or bag of words methods? And one more thing is that here some of empirical experiments showed that if we want to use a sequent branch of vectorizations, we should have a ratio 1500 between number of samples and sample length. So, for example, if we today have 500,000 samples of comments, we should, to achieve 1500 ratio, we should have a comment in the length in average 300 words. That's not usually the case, so that's one more signal to use bag of words branch in our pipelines. Now I will not talk you about those steps in a bag of words pipeline on this flow chart, but I will dive deeper over code samples and what and how to apply every of those steps. What are options? What is impact of decisions on different options, and so on. So let's go further. Okay, for this session, I prepared us a little toy sample to see exactly step by step how every of those parts of pipeline reshape and modify initial text which we use. First step here is text cleaning. Text cleaning contains a couple of sub-steps inside it. It's to translate the text to lowercase, to remove punctuation, to lematize, removing stop words, and we will cover all of those steps. So, for example, lowercase. Lowercase has a permission to avoid counting same word with uppercase, maybe in some moment like two different words. Vectorizers are case sensitive. So lowercase should rescale lower words to same level, to lowercase in this case. Next step is to remove punctuation. Usually we don't need punctuation, but I especially left this emoji to show you that last couple years, decades, people a lot use emojis to express their feelings. And sometimes this step should be controlled to not delete precious information in text. Today, I will not control that because we just do experiment, but maybe in production, you will pay attention to those. Next step is lemmatizing stemming. Probably can be describable like same mission like lowercase. Lemmatizing stemming have an, for a goal to translate words with the same root or same meaning on one word. Like if you see here in the first example, by, in second example, broad, translated by lemmatizer is converted in bye-bye. So we rescaled same meaning of words, two different words on one same, as we call, token. Next step is remove stop words. Here, I recommend you to pay really big attention to those steps. Personally, I don't like removing stop words on this way. Why? If you take a closer look in our example, what here stop words did. We had two samples. In first step, I like brand. They are good, I will buy again. I don't like negation. Brands, they are not good, I will not buy them again. Removing stop words, we will scale them on the same. Like brand is good, I'll buy. Like brand good, I'll buy them. But that's not correct. Also, positive was converted to negative, bad quality average price. So, for my opinion, at least pay a big attention what remove stop words will do. Later, I believe I will not forget. I will tell you, I'm counting there is 2 or 3 at least more filters later in the pipeline, which can use to control these redundant words. Okay, spelling check correction and the emoji I will not use today, but here I'm showing you how they can be applied. I'm just reducing in our workshop time of execution of algorithms. So introducing spelling correction and emoji would increase a lot of computation power, but in production, probably that's worth of that. Here is 2 libraries which control those 2 steps. Autocorrect for spelling correction, and here is an example how it's worked. And handle emoji have its own library emoji in Python. And also you see at the end thumbs up. It's translate emoji in a word. So to recap, this is my helper function for today. I will use those first 3 steps. I will avoid to use stop words, and I already said I will not use spelling collection and emoji. Next step is vectorization. So we now have a pretty much clean text. Now we need to translate it in numbers. Here we have a couple options. Main 2 are TF-IDF and count vectorizers. There is also a couple more like binary vectorizers, maybe some more, but two most popular are TF-IDF and count. They are 2 steps vectorizers. They contain first step called fit, second transform, and then I will tell you which step do exactly. In the first step, here is a function or applying method, how we apply fit method. Also, this is interesting. I especially prepared it. How much of you noticed that I switched the slide? It's amazing how easy it is to switch between those two vectorizers. You know, that's the beauty of sklearn and its standardization. So those 2 examples are examples of applying fit method of vectorizers. I will now go over main couple parameters which we need to provide when we declare fit method to those vectorizers. N-grams. N-grams parameter is the range of words or combination of words which we want to use as a features. On this step also, we preserved a little bit from sequent branch of NLP pipelines, as if we provide a multiple n-grams. Now I will show you like bigrams. Bigrams already takes two neighbors of words, already like a little sequence as a feature. So on this step, we declare what words and combination of words we want to use as a features. Here you need to pay attention that if you declare a too big n-grams range, that your amount of feature will be, your feature space will be huge. So you cannot go to infinity in n-grams, but here you can control what part of sequences of text to use as input. Next parameter is token mode. That's basically our answer on the first question in a flowchart. So here you provide your scope of interest in text. Our is word, so we set up here word as token mode. And minimum frequency, as I show you an example on toy dataset, on toy example, here you provide a parameter which should be used to exclude features which are not precious for predictions. For example, if feature is once appeared in a data set, that's not some relevant feature to use it in order to make good predictions. So this parameter here removes all features generated from n-grams which appears less than this frequency. And that's pretty much of this. If we run it, this is on our toy data set, this is what we will get. This is called vocabulary. And it's basically features which are stayed after all those parameters, and number tokens are assigned to them. It's basically dictionary Python. When we apply transform, algorithm basically takes words from dictionary and go over our comment, our text, and make a score in a TF-IDF case, make a score and assign score of every word in our dictionary. So this is an example how it looks like when TF-IDF transform text, and pretty much the same fit part of count is like TF-IDF, but transform is pretty much different. In a count part, we have integers. He have pretty much different way how to mark and assign number to words. Two main differences: count vectorizer observe just appearance, how much some word is appeared from dictionary is appeared in our sample. TF-IDF pay attention not just in sample, but how much that word is appeared in all data set. So that's the main difference. Okay, after vectorizing, we already have a vector of numbers, which we could basically put in a machine learning algorithms, but there is a big but. If you take a look to shape of your dataset after that step, you will see that shape is huge. So we need to apply something to reduce that feature space. We have multiple, in theory, we have multiple feature selection methods like filter, wrapper, embedded, But basically, we don't have a pretty much choice in NLP. Why? Wrapper methods are really, really computation expensive. They count in some moments like it, so still counts every possible combination of features which should be used in ideal model. You know, if you have like in our case, you will see later like a million features, amount of possible combinations between million features is like impossible to use something like that. Embedded methods, on the other hand, we can use in all again in theory, but we don't gain much because with the embedded method we again need to pass our large space, feature space, to some of machine learning algorithms, and to use or reuse like in maybe logistic regression or lasso ridge, use weights to determine what of that algorithm, which features he selected, and to inherit that knowledge. And basically, we coming up to filter methods, which we will use. Filter methods are lightweight, really stable option for NLP. That's our basically statistical tests, univariate on features, and pretty much successful on the other hand. Yes, simple, fast, and reliable, and that's everything which we want from feature selector. You see here, I show you training shape before feature selection. It was more than 900,000 features, and we reduce it to 15,000. So now it would be much easier and faster for machine learning algorithms to process these matrices. Next step is machine learning algorithms. For today's session, I choose to apply neural networks on TensorFlow backend and light GBM. Microsoft somehow, I don't know, my personal opinion, Google versus Microsoft, to see who is more successful. Here I showed you like basic architecture of all and declaration of those two algorithms. I will not dive deeper in any of those parameters. They are more or less standardized between machine learning algorithms, like learning rate, like objectives, like number of estimators or number of iterations and so on. And also this setup which I used is not much tuned, or not much time I didn't spend to tune them to be perfect. Just some basic parameters, and I wanted to see what will happen. On one more thing, I include one more player here. Often in last couple of years, I saw that people want to gain fast result of sentiment analysis. They use sometimes pre-trained models from libraries like NLPK, Spicy, and maybe similar to gain results of sentiment analysis without any development of pipelines. This is how easy it is to apply NLPK, for example, to get, as they called, a polarity score. Let me stop on a moment with the want to take, did I get result on test? I wanted to make scores. Oh my God, run out. I didn't have a luck today with the algorithms, running algorithms, because my light GBM was stuck with the IDF vectors, and I didn't succeed to get a score. I hope till the end of this session I will get them, or at least on second part of workshop I will come back to this table and show you what was scores on different vectorizers or different algorithms. For NLTK, I can say at least I was surprised when I saw success on test sample was nearly 90%, 89%. So I was surprised that the easy apply and really not bad result. Okay, what's next? With this part, we basically can say that we answered on first question. According to the average results of testing of those algorithm or their prediction, we can answer to business on a question about overall score. But that was just a part of our mission. Second part of our mission was to extract attributes which determines positive or negative sentiment. So second part of today's session will be about my way, let's say, extracting those insights. Here is in 38 rows of code how I do that. Now I will go over main blocks of this script to see you what and how I'm trying to extract informations to determine attributes of positive or negative, which attributes of product or brand, which determines positive and negative sentiment. Basically, my idea is with the trained model, with the libraries which process natural language, probably I have everything what I need. What I have in mind. For example, in first part, I'm taking from my light GBM model, we have an option to take a feature importance. I got a vector of scores, tree-based algorithms, how much some feature is important. But here is a small problem, that this is reduced space. So I need to translate back this reduced space to initial space, which was before reducement, before selector. So I used inverse transform from selector to assign properly those scores to features which they were initially. Later I will tell you why exactly I do that. Next step is feature names. You know, when I extracted important features and translate them in a feature space, initial feature space, I still don't have a names like you see above. I still don't have a names of those features. I don't know what's the name of those feature which score is assigned. So I'm taking from vectorizer one step back too. From vectorizer, I'm taking feature names and then assigning for columns in inverse transformer selector feature names from vectorizer. And basically what I got is I got initial text and their score. To be more convenient to use those scores, I'm transposing them, assigning score, transposing them, I'm sorting score like this, and then measure length of those features. For example, I'm interested in the combinations of words. Adjective by itself doesn't mean much to me. For example, good is not much information. Good what? Or bad what? So I'm removing here all features which have a length less than whatever I want here as a filter. Currently, I'm using less than 2. So, or I'm searching more than 1. After that, I'm using NLTK post tag. That's the library which marks words according to their grammatically family. So here I search. I'm not showing you both of those steps. First step, I'm marking all words, and in second, I'm declaring what words, what types of words I'm interested in. I'm interested in adjectives in combination with nouns, like good car, and as you see here, good stuff, high quality, free shipping, good review, something like that, combination, something like that. And with these 2 lines of code, I succeed to get that. But one more step is necessary. I still don't know what is the sentiment of those 2 words, combinations of words. So I'm coming back to my LightGBM model and passing those words by itself to this little pipeline. I already have a vectorizer and selector to this algorithm to give me an answers. What word is positive, what negative. And here is, of course, a bit of junk will pass here, but basically, as I made it in 38 lines of codes and with not pretty much tuning, results here are pretty much good. Basically, you can even with a small impact extract what are your strengths, what are your weaknesses, like great product, good stuff, good product, great review, high quality, or on bad taste, taste bad, poor quality. And it's funny, like in a real life, people have different opinions on the same thing. But also, that's also valuable information. What is the most important thing for your customers? Like I will make, if I would business owner, I would make a conclusion here that quality, taste, and maybe smell. Is there smell? Nah. Quality and taste is the main 2 attributes which I need to pay attention. And basically, that's it for our today's session. I would have in a plan, I had in a plan to analyze a little bit those results, what I told you in this slide, but unfortunately, I didn't give them yet. I will leave this part for part 2 of workshop, and maybe in a part 2 we will a little bit analyze and discuss what was the results of our algorithms, different vectorizers, also comparing with the NLTK as a benchmark. So thank you for your time. Hope you were enjoying. Hope you will find useful this first part of NLP workshop. Together with these slides, I will talk with Tatiana. I will provide you a source code, complete scripts, which contains all of those, like these methods applied in a pipeline, so you can play with them, maybe tune them, try to find out from your side does what works better or not, and that's it. So thank you guys for attention. See you on a second part soon.